Here is an empty 3 by 3 grid. The job is to drop the numbers 1 through 9 into it, one per cell, so that every row, every column, and both long diagonals add up to the very same total. 9 numbers, 8 lines, all balanced at once. So try the obvious thing. Just pour them in, 1 to 9, left to right, top to bottom. Now look at the rows, 6, then 15, then 24. Nowhere near equal, one honest attempt already broken. And shuffling helps less than you would hope. There are 362,000 ways to fill this grid, far too many to try. Worse, when a line fails, you cannot tell which number to blame, so you cannot even improve in a sensible direction. Pure trial is a dead end here, and a slow one. So we will not guess at all. 2 facts about this grid decide almost everything before you place a single number by feel. Find those 2 facts, and the puzzle stops being a shuffle and becomes a short piece of reasoning. Here is the first fact, that shared total is not yours to choose. All 9 numbers, 1 through 9, add up to 45, no matter how you arrange them. And the 3 rows together cover all 9 numbers exactly once. So the 3 rows split that 45 evenly between them. 45 divided by 3 is 15. Every row must total 15, and the same argument on the columns says every line, 15. You were never free to pick it. Before placing a single number, the target is already decided for you. Now the second fact about the middle cell. Look at how many lines run through the center. The middle row, the middle column, and both diagonals. 4 lines, and every one of them must total 15, so together they add to 60. But those 4 lines cover the center 4 times over, and every other cell just once. So 60 is the center counted 4 times, plus all the rest, which is 45. That makes 60 equal to 45 plus 3 centers. Take 45 off both sides, and 3 centers make 15, so the center is 5. The pairs confirm it. 1 and 9 make 10, 2 and 8, 3 and 7, 4 and 6, all 10, with 5 left over on its own. 5 belongs in the middle. Drop 5 into the center, and each pair now sits straight across from it. 10 from the pair plus 5 in the middle is 15, exactly the line total we were forced into. The 2 facts already fit together. Now the 10 pairs go straight across the middle, 1 number each side, so every line through the center already lands on 15. 1 opposite 9, 2 opposite 8, and so on around the square. A little care with the corners settles the rest. Each corner sits on 3 lines at once, a row, a column, and a diagonal. So the even numbers go there to spread the load, and the odd ones fall on the edges. One arrangement that works is 8, 3, 4, then 1, 5, 9, then 6, 7, 2. Now check it, line by line. Top row, 8 plus 3 plus 4, 15. Middle row, 1 plus 5 plus 9, 15. Bottom row, 6 plus 7 plus 2, 15. Every row lands exactly on target. The columns give 15 the same way. 8, 1, 6, 3, 5, 7, 4, 9, 2. And both diagonals, 8, 5, 2, and 4, 5, 6, are 15 as well. All 8 lines balanced, and not a single number was guessed along the way. The reasoning even hands you a bonus. Add 1 to every number in the square. Every line held 3 numbers, so every line grows by exactly 3. 15 becomes 18, and the square stays perfectly magic, just wearing new numbers. So here is the whole method. When a fill-in puzzle looks like blind guesswork, do not guess. Ask what is forced. Add everything up and share it out to fix the line total which was hiding in plain sight. Then find the busiest cell, the one sitting on the most lines, and pin it down the same way by adding up the lines that cross it. Once the total and the center are both fixed, the rest is just tidying up, and the whole grid follows. You deduce your way in, you never shuffle. Your turn. The same grid, but with 2 through 10 this time. 2 questions do almost all the work. What must every line add up to, and which number belongs in the center? Pause and work those 2 out. 2 up to 10 adds to 54. Divide by 3, and every line is 18. And the middle number now is 6, so 6 is forced into the center. Exactly the same two facts, cracking a fresh set of numbers. One more, a little sharper. Fill the grid with the odd numbers, 1, 3, 5, and so on up to 17. 9 odd numbers in all. What is the line total, and what sits in the center? Pause and reason it through. The 9 odd numbers add to 81. Divide by 3, and each line is 27. The middle number of the list is 9, so 9 takes the center, just as 5 and 6 did before. Different numbers again, no diagram to shuffle, and the very same two facts settle the whole thing. This way of thinking runs well past magic squares. A Sudoku is solved the same way, never by guessing, always by asking what a cell is forced to be. Any balance puzzle rewards the same first move. Stop and find what simply cannot be otherwise. That is where the answer starts. So a magic square is not a lucky shuffle. It is forced. Add everything and divide to fix the total, pin the busiest cell by the very same logic, and the rest of the grid quietly fills itself in. What looked like guesswork turns out to be 2 clean steps of reasoning and nothing more. That's all for this video.